So what you end up with is a yin yang at that point. It's exactly that configuration that allows for the equilibrium non-equilibrium state to occur, and that's what has to happen in order at high enough differential. So if you're able to bring enough atomic mass in from the cathodic side and trap it in the energy side, what you end up with is two hyper density levels. On one side, hyperdensity energy of high, high energy potential, and then on the other side, hyperdense low energy potential. Matter and energy separated at two very high points. Those high points, if concentrated enough, would be enough to break the locality with the environment, just because
Mm.
of those 2 points. And that's the idea that I'm bringing to light here.
So they do that with nuclear missiles. By the way, they take it they strip it so that they don't cause a reaction before it's ready, on the triggers. Um, but is that the difference in the, what is it, red and blue shift in nuclear?
It is.
Okay, just making sure we're on the same page here.
Yeah, we're on the same page. And the red and blue shift is funny because it's like the, the shift could be both at the same time. It's just depending on where you look, huh?
Yeah. I think, Joe, I think we're pretty good on that. I think the it's not so much what's going on there, because I like the disc for what they do. Okay. So we put the motors on them. They seem to run very well with high voltage on them, not a problem. Um, we fixed some of the problems that went on in there, in order to structure the frequency properly. Okay. So let me say it this way: when your high voltage is on and your motors are on, you have to adjust your motors to your high voltage state. Okay. And what they'll do is they'll start to shake the craft because it goes into mechanical resonance at that point. Right. So that's how you know you've achieved that portion. Now you'll have to readjust it when you turn the Tesla coil on. And here's the thing: you have to use high voltage, okay, leaching in order to achieve this next effect. Okay. It's like putting in a sine wave over your square wave in order to change the frequency of high voltage in DC, but it's on the opposite end. It's on the back end of it. So what you're doing is the high voltage leaching is changing the frequency of the DC flyback, which I'd like to use AC this time instead, just because of the RAV and the way it works. But it takes that DC high voltage from the DC flyback, and it takes the Tesla coil energy, and it takes the frequency, and it now doesn't make them the same, but it brings them closer together. So remember we talked about the RAV and how it went, between 4 kilohertz a piece in between each field. We're tightening the field on it. And what we're doing with the motors themselves is they're in thirds and fourths of the frequency that's going on in the high voltage,
Mhm.
which now means we have our three fields correct, right? We're now putting it in to resonance in all three zones now, because we got a mechanical resonance going on. We now have the two fields on the outside in resonance with the mechanical, which means that we're turning the aluminum itself into a superconductor by the way that we're doing everything. That's what it means. The three levels of resonance to the aluminum makes it a superconductor in this field with the red and blue shift.
Yeah, and once you have a superconductor in there, like again, the nature of superconductor is that it's no longer going to be affected by the same rules of physics as your ambient environment, which is the locality break.
Mhm.
So more or less, it ends up slipping and sliding through anything at that point because its relationship is broken. Um, and that's what happens when you reverse a non-equilibrium state. And that's sort of the awesome point about it, that when you reverse the non-equilibrium state, uh, because it's like I said to you on the side, matter is, or I should say ambient matter, okay? Ambient matter is actually a entropy trap. Okay, so it it maintains the entropy state as we know it. It allows for the transfer of heat. and high and low energy potentials, depending on its excitation of other environmental factors, which is how it gets passed along. Okay. The thing about it is that it contains both parts of the yin yang, the black and the white, which is
Hmm.
why that happens. It's both because why? Because it's atoms have electrons. You see that, and that's sort of the key. The atoms have electrons, so they have both parts, and that's what allows it to bond, and that's what and create new stuff and so on. Well, once you break those electrons from the atoms, and then you keep them separate of one another, well, they're always in this state of wanting to attract back with themselves, because before they wanted to attract to other pieces of to accumulate and bond, but they chemically can't do that without valence electrons, right? So there becomes this interesting chase situation that occurs, right? It's this chase situation that is the exchange, that is actually a huge abundance increase in energy, because there's energy that's required for this chase to occur, and it's not coming from anywhere other than their natural, predisposition, to
Oh,
want to combine.
okay. So now I agree with you, by the way. Um, we have the structure of what we want to work with, but you didn't like the aluminum on the outside, the foil. That was my starting point. Where do you? I mean, I obviously would like a layer of aluminum on the outside. You know what I mean, like a thicker layer, maybe
Yeah,
eighth inch or 16th.
yeah, I
Yeah.
would say a shaped aluminum plate, one that you bang into shape, or the better thing would probably be like a milled billet, frankly, like something that's really solid, that's, I think, ideal. But yeah, I just don't think that it's not that the aluminum with the aluminum foil is the problem. The material is not the problem. It's the mass of the material that's the issue.
Now,
Um,
I asked that based on, okay, because we're looking at taking out the center plate of this thing. So is that replacing the mass of the center plate in what
Well,
we're doing then?
you'd have to exceed the mass of the center plate. But I mean, if you're using foil and this is your creative thought process, I mean, who's to say that you can't layer and compress different foils even to get multiple different conductive properties out of your shell? You could get different materials in foil and literally layer and compress and layer and compress. You
So
know,
we've done bench testing on like a Tesla coil inside of a Tesla coil, um, where we're able to convert the fields properly and get it to ring out. So would you suggest the same thing that we do with the tin foil to see if it's going to be thick enough to start with?
I mean, it's always worth a shot. I mean, I think that there would probably be some kind of result, right? Like something that you would be able to see objectively that would tell you whether or not that's the right direction or not
What
experimentally.
what if we used a capacitive state? So we took the aluminum foil and then we put a layer of plastic in between it, thin layer of plastic, just like building a high voltage capacitor. Would that be better? And then we could put another layer of aluminum foil over it. You know what I mean?
That's how I got that cap to float and then lock down to the table. You see, because in that configuration, that was an aluminum cap, and it had two like spins of wire around it that was coming from a makeshift, um, capacitor that I made, and then it was being discharged through a coil that
Mhm.
passed directly through a piece of aluminum foil, okay, that had a flattened quartz crystal inside of it. Um, so it's kind of the same idea. That it was running it through a capacitor, creating a magnetic vector, bring that magnetic vector into a reverse wound magnetic vector that was completely 180 degrees opposite of it, and then passing through the flattened and compressed aluminum that had again it was very thin, a thin, flat piece of quartz in the middle. And, that was just kind of pushing the energy around the quartz, but that's enough for it to, is still reach a point of excitation. And then it had an internal pulse because of it at its own native frequency. And like you didn't hear it, but like it would kind of hurt your inner part of your ear. You know what I mean? So it was definitely screaming something. And again, that was enough to like get that cat to suck to the table and do weird shit and kind of quasi mess with time, that sort of deal.
Yeah, I've had them hook the DC flybacks, man, and like aluminum foil flatten out on a piece of table as soon as you put energy to it.
Mhm.
So are we okay trying that in the beginning for our first run, like a capacitor situation, and just overlay the plastic to each other and put a piece of tape on it, and do the foil overlapping, and then create the capacitive state on the outside, because we got to try something in the beginning.
Yeah, something's got to give. And I mean, mind you, how effective that ultimately could be, even though not ideal. It might not give you the mass differential that you kind of need, but at the same time, think about how effective like a Faraday cage is at keeping electromagnetism sort of like out, right? Well, I mean, this is similar circumstance to that. This is just over and it's gonna be
Oh,
pressing
okay,
back in. So I
create a
mean,
higher compression.
you're gonna get the better compression regardless.
Mm. Sorry to interrupt you, Joe.
No,
Yeah,
no, no.
I agreed like halfway through. I'm thinking, yeah, because oh man, I got a guy out there who's done this, and he's created something that's lifted, and he does it the same way every time.
Mhm.
And it's ironic, and that we're talking about it this way because it's exactly what he did. You know what I mean? Um, so yeah, a higher compression state. So even if the outside was fairly thin, but was a different material, like a heavier material, it'd still be okay. So if we went like a 16th inch, as long as it's real nice and clean, it's not real sharp. You know what I mean? No jagged edges. Has to be rounded on the outsides, because every time you make a jagged edge, it's horrifyingly bad on
So check
everything.
this out real quick. Um, what you're kind of trying to create with this, all right, is sort of like the surface of the sun. And if you've ever seen the surface of the sun, where you have like these, it's like an eruption, right? And it pushes out, and then pushes out to a certain point, and then it kind of cascades over on itself, and it comes back down from where it came. You see, it's sort of that same circumstance. You need it to put the field out past the material, okay, while remaining in compression internally. But then you need it to actually reach like a point where the greater attraction of that field, is back down where it came, you know, and then it returns. And that's sort of what needs to happen. You see, like when you used to run Graviflyer tests and you would say, you get your room saturated and so on and so forth. That's because it's working on the same mechanism, but a different principle of that mechanism.
Hmm.
You're depending on changing your ambient environment enough to then induce something internally within the Graviflyer, to create a differential that it's able to sustain and control. But in this, you almost you can't sit there and depend on um, saturating environment, you know,
Hmm.
because it's just too much of a loss to ever get the differentials correct. To have it reliably and consistently, operate and work. So what does that mean? That means that you need to be able to change your ambient environment, but only slightly and at the surface, and then have what's changing it come back in to be able to maintain the high density levels within.
So check this out. I'll give this reference again. Courtney Sams, when we went to look at his Tesla coil, remember I told you the exercise ball, he put the aluminum foil over top of it, and then we
Mhm.
got that nice, beautiful field on the outside. Now his is a much, much higher voltage than what we're going to be running, but there was like three inches at least around the top, and you could see it It completely structured everything around it in the air. So I'm thinking we're doing the same thing by putting a cover over top of this thing. You know what I mean? We're gonna get maybe not the same, height, but we may get like a little bit, and we'll be able to see it in the air. It'll change the air pressure right around it.
Uh-huh.
I, and I think we're gonna get what you were describing
That's
is
it.
uh, is that exact zone right there that we needed to find in the first place. That we're not getting a whole lot of the times when we do Graviflyer tests. Too open.
Exactly. Too open. And that's been it. There's been a huge loss of compression. And I've been kind of saying that for a long time. It's like enclose the thing, close it in, and then just find the material properties and the right vectoring to be able to throw the static off, but then have the static re-vector down,
Mm-hmm.
and that's sort of it. And the way that you could probably do that is, by if you throw scalar rather, an oscillatory type of waveform, when you throw that through a medium, and it's enticing that medium, and it's a dielectric, right? Chances are you're probably going to get static accumulation on the other side. Now, if you have magnetic fields that are on the inside that are keeping the compression, they're not outside the reach of the magnetic fields, and just like any sort of wave or whatever, like a gust of wind, since we're talking about gas, if you want to think about it. Well, what happens when you take a loose leaf and you let it go in a gust of wind? It goes with the wind, right? So, well, then the static would come to the surface and get pressed out, wouldn't affect the magnetic field at all because it's oscillatory. And then it would just come back in. So it goes back to resonance because the scalar in this case would actually be oscillatory. Um, so it would kind of just be a little shake almost like uh, indiscernible, you know. It's my thought process about it.
Hmm. You know, sorry, in thinking about that, we must have compressed the gas inside of there, just the air itself, like whatever the air had in it, you know what I mean? Whatever that structure is inside that workout ball. I mean, think about that. It's already under pressure. Now
Mhm.
the electric field on the outside put it under more pressure. So it forced it to respond by putting the field on the outside and giving it more radiation that it should have had, which gave us a better break in the environment right there around the craft. And I think that's what we were missing the entire time because it gives you that look when you look at it. It's like fuzzy in the air. I don't know a better word to say, like shimmering maybe, kind of. You can clearly see the state where it went from there's the solid object and then there's the field. Like it was clear as day. It was right there, and it did the tunneling before the electricity went. So I think that ties into the next part of it is the vector direction in it and how that's going to work. And it kind of changes my view on it a little bit because of what we're looking at. Because we had a breakout point that shot the electricity to the destination it wanted to go to, and it didn't come off the craft until the field was actually structured out. It would go and structure this field where it wanted to go. I mean, exactly where it wanted to go, and then you saw the voltage just jump right afterward. It was
Mhm.
like a 1-2 punch every time. And I'm thinking, man, that opened up a zone in, like, I want to say it's dimensionally different than the air itself because it opened the air and the environment to a um like a non-pressure zone or a non-inertia zone. It allowed the energy to flow freely without any kind of interaction to stop it.
Yeah. And I mean that makes sense. And I mean, anytime that you're creating a variable, right? Or the other, whatever is the higher pressure was the example, right? So whatever the higher pressure is going to rush in to fill the space of where the lower pressure is created, right? So that's what creating your differentials does. It actually creates movement of the ambient. Um, it's just interesting to think about. Uh, yeah, I think that your Graviflyer testing in the initial phase I feel like it was doing mostly everything that it had to do. It was just allowing it to go too diffuse and then wasn't doing what it had to do internally to get the compression levels needed to create the differential with the environment, you know? And the environment in this case was more in tune with where it was than what it was ambiently, actually creating um, less of a differential. Now, remember, less of a differential is more ambient, is more equilibrium. All these things are, these are all the same words, you
Yeah.
know. Ambient and equilibrium is, you know, something, an ambient measure of an area is the equilibrium of that area. That doesn't mean that it's the same every single where you look, but you know, in this case, that's what it is, right?
Yeah. Well, I think, and I'll just say this. Remember my Rodin coil test where I put the wire down the center of my Tesla coil, and I had my Rodin coil, and it would light up the light, and then it would stay lit when we moved the wire out of it. It Here's what I think happened, and I think it goes right along with the Graviflyer. It was trying to make it a superconductor, and then it was trying to hold the energy in, so the inside energy, until it was dissipated, it didn't turn off. So it gave it the time, maybe it was 5 seconds, 10 seconds, whatever the time was. It held the energy in until it was done using all of it that was inside of it. So there was a field being created around it and it stayed inside of it. So that's how we knew that the Tesla coil, what its job was. You know what I mean? That it was holding things in. Now, there's other tests that prove that, but I'm just saying as a reference here to some of the work that we've done in the past, that's exactly the way it feels. Because even the Tesla coil, it didn't shut off right away, man. When we were over there looking at this thing, that field did not go off when it turned everything off. It stayed there for a minute, trust me.
Right. Um, all right. This is the mind bending part about it, and it's kind of quiet part out loud too. You know,
Go ahead.
but you know that superconductivity is the antigravitic property. Okay, that is, and well, it's also the free energy property and the 100% efficiency property. It's all those.
That's what
All,
everybody's looking for.
right. So now everyone's looking for it, and in a laboratory, when they achieve it, how do they achieve it? With super, super, super cooling, right? Well, what does that mean? Well, that means that you're bringing everything to its lowest possible energy state. And then that means that in the ambient environment where it is, it's in a super low energy state. Anything is higher energy state than it. Therefore, there's no friction, there's no relationship, there's no it just is broke. You know, it broke that locality relationship, and actually needs to stay in onto itself because more matter is going to get repelled, but for its energy, that potential that it contains, which means that the mechanism of gravity in itself has to do with matter and its interaction with energy potential and the densities that exist in the relationship between the objects, which is why density directly plays a role, because the more molecules you have of a particular element, let's say, the more mass that you have as we see it. But what that means is more mass in relationship to energy. And that's what you end up seeing. And it's really kind of it starts to make a lot of sense when you start to think about it that way. So what does that mean? Well, that means that we've spent, and not only us, but like everybody, has spent so much time running these formulas as to how much energy you would need to break these differentials, right? And it's astounding. It's an astounding amount of energy all the time. It's usually more energy than we can produce to achieve the result. I mean, think about it, even a rocket ship on liftoff and how much fuel it takes and energy it takes to lift that off, right? Just to defeat the gravitational. What happens when you realize that it's not how much energy, it's how little?
Well,
Like,
but but that's the problem with the math, isn't it?
oh yeah,
Okay,
that's what
so
I'm saying. It's not how much energy, it's how little.
Yeah, but it's the word is condensed. So we're looking at the amount of energy to pull away from the earth, right? But that's the wrong answer to the wrong question. Okay. You can't calculate out the amount of energy you're going to need to repel yourself off the earth because it's too much energy in the environment as it is. Okay. You have to create the entropy needed inside the system in order to make it different than the environment condition around it. So it has more energy condensed inside of it than the actual environment does around it. That's why entropy is important. It must take that into account when you do this. It's a state in electricity that not everybody puts in there because they don't see it until they get to the higher voltage states and they don't understand it. It's always in the system, it's always in energy. You just don't see it, and it's a calculating factor you have to, and it shows up everywhere. But that's the point, isn't it? Is that's why you build the field bubble, because
Mhm.
we don't want to deal with the energy in the environment in the way that everybody else thinks of it. That's the wrong way to see something. We want to see it inside this little bubble. That's the only thing we want to see is we just want this field to have the exact same structure as the structure of the earth, but inside a little bubble. Why? Because we know that the earth is a gravity well. In order to create the gravity well on the inside, we have to produce the same states, right? So it's funny how we looked at it because we said high voltage potential, what we see in the upper atmosphere, high voltage potential. We said a magnetic core, right? That has eddy currents everywhere. What do we see in the center of the earth? A magnetic core with eddy currents everywhere. What do we see in the outside plasma field of the planet? We see the same thing we see as an impulse field of the Tesla coil, right? On the inside of it, which could build to a plasma state based on how much energy you have, which is the exact configuration that we're looking at when you put the exercise ball with the air inside of it compressed and you get that field on the outside is you're getting your plasma state. Okay.
Mhm.
It is a perfect gravity well because
Mhm.
it's building the RAV from the inside out, not the outside in. You're going reverse. We're building from the inside out.
So,
You know what I
so
mean?
what's weird, man? So the reason we have non-superconductive properties, okay, is because the ratios are non-conducive. And here's the proof in the pudding with Earth. Okay, you said it yourself just now. You have all this atmosphere. Okay, now let's mind ourselves as to what atmosphere is. Okay, it's gas that is in a diffuse state that becomes more and more diffuse the further out you go. Now, the further out you go, also the higher the energy potential levels are.
Hmm.
Okay, so you have a diffuse state of matter with a higher energy potential. Okay, but then when you look at the Earth, okay, you have a lower energy potential, higher density of mass. Okay, but then you look all the way to the center, and then what do you have? You have this core, okay, that is extremely high energy potential. Okay, and that's your yin and your yang of Earth that exists. The thing
Hmm.
is that the ratio throws us into a state of equilibrium that is this, and the differential offset is that of our gravitational forces. Um, so to overcome that, what do you need? Well, you need higher energy state in the diffuse side of the matter, and you know, and vice versa, higher density states and the highest energy potential states, which is like in the core of the Earth, so to speak, right? So if you actually had those two things, all of a sudden that offset differential widens, your gravity level goes down. All of a sudden, you're in a a non-locality situation, superconductive environment.
Well, one of the things that's missing in this, we don't have the crystal state inside of anything on the Graviflyer. Okay. And it has a certain property to it that you need in some of these devices. And I mean, you can achieve it by grounding this thing to the ground while you're pulling in the energy necessary to create the field bubble, right? But it's an absolute must to have it in there. And if you do it on the table, it won't achieve that state. It will not achieve the same state at all. I mean, it's crazy how that works. I put it on concrete, I put it on the table, you know what I mean? I put it outside, I put it on tile, I put it on the earth, and I get a different field.
Yep.
Okay. I have a direct connection to the earth. It's so much harder than any other way. And it has to do with that crystal inside the earth because of the way the earth builds out and it creates crystal. We see it in, some of the stuff in the RAV that we work with. And I don't want to go too far into it, but it has a direct correlation of why it needs it. You know what I mean? Because it's the original state that you must create.
Yep.
Therefore, it must be the state that has to be in it that we're missing. So I think the way that UFOs got away with this is the aluminum, bismuth, aluminum on the outside. They had the crystal state in the bismuth, okay, but they also had a state in there that was more like a lead state, okay, and it was going in between the two. And what it would do is it's a high reactance value, which is the same thing that it gives you inside a crystal. It's a bounce in, bounce out. It's a frequency match. It's the properties of it that make it worthwhile, but it's also the reason that in UFO devices you get the outside is aluminum because you need the eddy currents and you have to have the aluminum because of that. You have to have a crystalline state in between. So you have to have like a bismuth, but you also need some of the values of lead. Then you get into aluminum again. Okay. And I think that's the correct structure on the
Okay,
outside when we get
so
there.
check this out. Get yourself like a steel mixing bowl or something like that. Like how they have steel mixing bowls. I don't know. I have one. Anyway, get yourself one of those, and then you get yourself just some aluminum takeout containers. Okay, and you sit there and you spread the frigging takeout container on the outside of the bowl, and you tap it and whatever until it's like formed around the bowl, and then do the same exact thing on the inside, and then basically just pour frigging liquid bismuth into the bigger bowl, and then weigh down the you know what I mean? Weigh down the smaller one, and then you'll just have a gap in between that creates, that'll solidify with the bismuth, and then call it a day. And whatever shit like spills over, just take like a fucking grinder and you know what I mean? And that's it.
Well, the bismuth in a liquid state would still not burn the aluminum.
No, exactly, and that's the point, right? So
Right. So you
that's
could
why
just
I'm
create
saying
each
that you
layer.
can
Yeah.
mold, right? Yeah, you can mold the bismuth right into the aluminum, and if you wanted to keep shape and have it sandwiched, all you need is a bigger half and a smaller half that are kind of proportional. Well,
Yeah.
what does that do? A bowl, right? A bowl. If you shape it to the outer, shape it to the inner, you just have a small gap in between.
Yeah. No, I'm there with you, Joe. And I think the heavier the craft is, the more it's going to need that structure on the outside. I think that's the mass factor. Is the more weight you put into it, the more the outside structure matters. Is what I'm trying to say. I think in a low system, like a small system like this figure round, I don't know that it's going to matter as much as long as the outside field is saturated versus where you have a heavy item, that outside field has to play a different role.
Yeah. Well, quiet part out loud again. Once you get the ratios exactly where they have to be, what you end up with is a very pinpoint area of super duper high density matter or mass, I should say. I shouldn't say matter because that's not correct. Mass, okay? And then on the other side, you have super high pinpoint of energy, right? And it's these pinpoints that create these high differentials and the separation of the two, okay, in their own more diffuse states that are still in a density compressed state, right? That allows for all this to happen. And I mean, again, I said quiet part out loud, right? What does that sound like? Well, it sounds like a black hole and a white hole to me, doesn't it? Because now you're dealing with something super dense mass, super dense energy, and they're in a state of exchange. So call it what you will, like, I mean, I'm not saying that it is a white hole and a black hole, but based on everything that we ever kind of touch on the subject, it certainly seems that way, wouldn't it?
Well, I think there's an energy exchange for sure. Okay.
There has to be an energy exchange,
No,
or this doesn't work. Yeah.
no,
It's got to be a dual energy exchange. Yeah.
one of the craziest things that happens on those energies, because they're on spinning discs, is they create a center point, and whatever the center of mass is a center point, right? But that center point usually it creates an energy node in it, so it'll pull vortexes from the top and the bottom, and you got a hot zone and a cold zone. This goes into our vector direction directly into it, because before it had to do with the piezoelectric disc, and it pushed on it, and it was pushing on the field, so it'd make it look like a bean on the bottom. You know what I mean? And then the beam would pop and it would jump. I don't know that I like that method at all, to be honest with you. I'm really not a fan. Um, I think there's an easier way to get there, and we did it in the little paper lifter experiment that I did, and it was simply you create the little ball at the top, you put the rod down the center, and you make everything go to try to go get that ball at the top. You take plastic to build this thing, and you have the ball at the top, and you're basically pushing energy up here so that it follows it. You want the mass to follow the small object. And anybody who's done electrostatics would know that that's one of the anomalies that most people get in how they build stuff, but it's the exact way we need to do it here. And it has to do, how do I want to say this? It's tapping it. So if I took anything that had high voltage on it, say a plastic rod, okay, a piece of PVC, and then I had aluminum foil down in ridges, and I tapped it once, nothing would happen. But then I tapped it 3 or 4 more times, what would happen is the whole thing would start to convert and the energy would shift. So it would become opposite to each other instead of going to the normal direction. Normally it goes down, then this way it would go up. It's following it in a different way. It means that it now changed, instead of the small always following the big, it changed to the opposite and went the other direction. So it's just a different way of looking at it, but I like that better than playing with frequencies and trying to push down a field. And
Yeah.
that's just
Well,
my
I
thought on
mean,
it.
I think that when you start to, okay, and what you just said, but then paired with what Yanni said, because it's interesting because it doesn't seem related, but it is, right? Yanni said, hot air rises also, preventing it from rising. Maybe would something get hot? Would something be getting hot? Right? I mean, it was just him saying hot air rises, and this is sort of the interesting thing. So we all know that hot air rises, right? But what's
Hmm.
in your entire room? Air. Okay, so so what's the difference? Well, it's the level of excitation. It's the energy density of that particular air that causes it to rise. Okay, um, now again, that has to do with density, right? So it's lighter density because it's in more excitation. So because it's moving around more, okay, less of it is able to fit up there, therefore it's less dense, therefore it rises, right? So we have this nice logical train of thought. Now, if you were to take a nice burst of hot air and let it rise up in a room, right? The hot air is going to be at the top, and then there's going to be like the ambient cooler air at the bottom, and then there's going to be this zone in the middle, right? That zone in the middle is going to be the destruction of the whole entire thing. Um, that zone in the middle is going to bang into, that hot air is going to bang into the slower air, and then that's going to get hot, and then it's going to just happen and happen until the whole entire room is the same, and then it's a, you know, it, the lowest entropy at that point, right? So, um,
Well,
but the idea here is this, right? That means that the states of energy naturally and natively want to separate, okay, and it is but for this this interaction that must occur, right?
mhm.
That that creates the entropy. Now, if you put that hot air in motion and you keep it moving amongst other hot air, and then you keep the cool air moving right parallel to it amongst other cold air, then they don't mix like that because they have a laminosity to them. Their densities are different. Therefore, everything about them is different as far as how they move. And then what you get in the upper atmosphere when you get like turbulence and things like that. You would get skipping, right? So it's that skipping that is the lack of the interaction because every time it skips, okay, it's not in contact with and not interacting with. Skips, not in contact with, not interacting with. So the magic happens, okay, see, so the reversal of the entropy actually happens naturally once you bring the differentials on two opposite sides, which is the whole point, right? This is what we've been saying about RAD from the get-go, mind you.
So you're
Right?
saying that
Separation differential.
we don't need to create a separate thing. We just need to get the differentials right.
You just need to get the differentials right. I've been saying it from day one.
I like that even better.
All you need to do is control your gray zone. If you have black and white, you need to control how the gray zone. The less the gray zone, the closer and better you are, because then they're not mixing. And when you get the mixing is interesting. You get other stuff that's awesome out of it. When you allow for this controlled mixing, this is actually where your matter creation comes from. Okay, and actually is what the transmutive elements of this are, is when you control your gray zone. So the whole anti-gravity equation with it, half of it happens naturally. That's why it's related to what you're saying. We're playing with all these different field vectoring and stuff, and I agree, all these things matter. But as you see in the RAV, it all kind of unfolds naturally once your differentials are close enough. Okay, there's certain thresholds that exist. Your differentials are close enough, bang, now all of a sudden you have all your electromagnetic modes that are
So
present. But then
the
you have to get those differentials correct in order for the interaction to be correct, in order for the density levels to occur, etc.
so where I left off on the Graviflyer is I couldn't get the frequencies aligned properly. So remember I told you how the RAV builds out, right? I couldn't nail them properly, and I blew out probably, I don't know, 5-6 motors in a row trying to get that thing to go. Learning the RAB in the meantime helped out a lot in figuring this out. Okay, and I would say this: we're using a DC flyback in the Graviflyer, and this is why I say I wanted the AC flyback. Is that push pull factor? Remember how I always say this with Sean, and I try to tell him either one can be positive and negative. It all depends on the pressure you put on each one. And then it'll change the actual magnetic field inside that AC flyback to be positive or negative on each side. It matters because the DC flyback doesn't allow that. You cannot build a big enough magnetic field on the outside of it to push back into the center of the magnetic field to have that push-pull factor. I think that was my problem. I couldn't get them to align because I couldn't get them to coexist together. You know what I mean? Now I can get them to coexist together based on which, one I'm using. And I saw the same thing when I do my peanut coil, my bipolar.
Yep.
It's the AC slush factor. So,
Mhm.
and I say that, I know that's not a particular word that everybody uses. I just say it's like in between AC, they always say it goes like this. And I just call that slush because it's just moving back and forth. But it's important because of the aluminum effect to it. When you put AC to aluminum, you get levitation. Okay. If you take a coil and it's in DC, and then you automatically switch it to AC, but you have an aluminum ring right there, it flies off. Okay. But it's the same effect of a Tesla coil inside of a Tesla coil. Okay. When you put a DC flyback or an AC flyback on it, and then you put a Tesla coil near it, you're going to create the same AC field in there, so any aluminum would go flying. In
Yeah,
thinking about that, when you just said what you did, okay, and everything's aligned properly, I've already created my direction based on where I put my positive and negative. I just need my coil to work with me to get it right.
that's what then that's it. When you were like, to get all these components in line, and that's sort of where you left off. It was like you, the theory of it is that, but the engineering of it is less because of what we've experienced with the RAV experiment. Um, you notice that the things naturally unfold. And with the AC, you kind of think about it. You have everything slightly out of phase with your waveforms, right? And um, it would give you this greater ability, you know, to actually um, have multi-mode vectoring. Okay, because each waveform, yeah, it might be interacting as it goes. Okay, but it always has something behind it, and what's behind it is never going to react. That waveform, the second and third waveform, they're never going to react the same as the first. Which is why you end up seeing a lot of layering type effects and smoothed out variables. You don't see the variables because they're smoothed out in the result that you see. But when it comes to then a revectoring, that second and third have a greater vectoring potential than the first that's been more so modified. That's why it's smoothed out. Now, the idea here is if you want to think of an analogy, right? If you were to take a garden hose, okay, and you were just to run a single stream through this garden hose and then have that one thing of water change its vectoring constantly, okay, it would it would be very turbulent, okay. But if you were to take one garden hose but then put three straws into a garden hose and run the water through all three straws, okay, where the first one, okay, actually is going to create the turbulence first, the other two are going to travel through those turbulence easier than the first. Okay, so they come through more unscathed. It's an it, you
Hold
know,
on.
and that's what
Here's
you see in Sean's oscilloscope readings when you look at his phase testing. That's why one's affected more than another, and it's slightly built up.
well, he's getting laminar flow.
There's a lot of laminar flow going on, which is kind of key to the whole thing. But you can't re-vector at first without there being some type of turbulent losses.
Okay, but hold on. I wanted to pull the vector direction out, which means what I mean by that is simply I'm going to pull a direction that goes straight up. And here's how my mind thinks about it, Joe. In order for lightning to work, the clouds have to play a role in the distance of the high voltage. It has to come down. Once it comes down, then it can reach a point where it constructively hits the earth, right? It's going to keep doing that. But in that, it has a higher voltage potential right at that point where it comes together in that electricity to give you a lightning bolt, right? But that's exactly what I'm looking for. I already have the high voltage up here at the top, right?
Uh-huh.
I have it flowing and it's in a constant spot. I need the point where it's going to get up and get to it. So I need the cloud to come down, right? So that's all I'm looking for is the not AC everywhere. I need AC up here.
Hmm.
So as the AC flyback goes and it's going back and forth, I needed it to have an AC slush state at the top once in a while, right? And as soon as it does, it gave me my direction. That's what I basically brought the cloud level down so I can get my lightning. And as soon as I got my lightning, I got a concentrated amount of energy, which gave me direction. You know what I
Hmm.
mean?
I
That's
do.
what I'm looking for. That was my non-equilibrium state. That's my, you know what I mean, pointing vector.
Hmm. No, yeah, yeah, for sure. That's it. It's just all this, like you've been saying, man. It's all this push pull thing. This push pull thing is the whole entire. It's actually hilariously funny once you understand it. You're like, holy shit! It's all
Yeah,
just
it
it's
was
just
right
this
there in front of me the whole
attraction,
time.
repulsion. space deal that's going on, and that's all it ever is. So if you just maintain the space and you allow that to occur, and that's able to happen, and then you hold it in, okay, then that's most of your components all right there. Because once those two have the relationship, they cross. And
Mhm.
once they cross, they have a different relationship. Okay, the two parallel is 2D. Okay, two cross is 3D. Once they cross, and then they create a third, which is the relationship, the beat between them. Okay, that is created, is that third vector. That third vector, though, then creates other structures, which is actually upping the dimensionality once again from 3D to 4D. So it's all dimensionality in how the vectoring works. Um, and that's the whole point, is that the vectoring is equal to dimensions. Um, yeah, I mean, once you get your head around that, and then you realize what the exchange all is, and it becomes very not that hard, I guess.
Yeah, well, the magnets prevent. Oh, the magnets prevent you from having the negative change. You know what I mean?
Mhm.
Which means it creates a higher compression rate for the positive, which gives you the AC pushback because it'll try to push to the magnets. The magnets will take charge in that field, push it back the other way, gives you the AC side of it, which will happen in a very small state because what's happening is you're amplifying it all at once in a, oh my God, that's insane. That's why he turned off the button. That's why the button turns it off. That's why the piezo works that way, because son of a.
You just realized that, huh? I did too. As soon as you said it, I was like, oh, I see where he's going with that.
It's why he did it. Now it makes all the sense in the world. Like I don't know that I could describe it right now, but it just suddenly clicked in the energy because you have to follow the flow.
Mhm.
Once you follow the flow of energy, you understand the conversion of it, and then you can understand. I'm just like mind blown, dude. Wow.
Yeah, when you get the piezo, when it pulses, you know, you're increasing instantaneously.
Well, it's
So,
it's not that. It's he's he's depressing a state of it all the time, and it's built out around that state. Once you remove that state, all of the energy goes to one portion, creating the AC, which causes the feedback that goes into your coils. Okay, that's what it is. It's not that you push the button to move up. It's you put the button to turn it off. Okay, you're shutting down part of the equation, right? That was compressed all the time.
mhm.
That's why he aligns everything first. Okay, but I don't know that you need the piezo in the structure if you know that. You get what I'm saying? So
Yeah,
I built all kinds of circuits that I did it in the reverse direction because I always hated the fact of turning it off. I just wanted to amplify it. You know what I mean? I wanted the effect without having to go through the pain of the cause. Okay. So what I would do is I'd make a snubber circuit. So on your Tesla coil, you make a snubber. So what it does is it takes the feedback that goes in from your Tesla coil, same thing you're dealing with, right? It goes back to the feedback of the Tesla, pushes it back out to through a diode to a capacitor, fills up the capacitor, right? I want to push the button at the end of that capacitor and let it flow back through that number two coil. Okay. That way I create it's like an amplification jump, okay, on the same frequency. I'm just putting in I'm dumping the capacitor right there. Okay. Boom. That's what
I
I've
mean,
been
right. So there's a couple schools of thought, I would suppose, and one and the other, but they both are similar in the circumstance, right? It's sort of like a skim board, right? It's like, you got to wait for the wave to come, and
uh-huh.
then you got to jump on the skim board for it to ride the surface. Killing the power at the right time with the right conditions is the same as finally making contact with that skim board, taking the skim board from one environment, putting it into another. Um, you know, but what you're talking about is the same thing, except rather than waiting for the wave and then doing the jump on at the right time. You're talking about Puck waiting for the wave, run with the board to the wave, and then with the speed of what you're running with the board plus the power of the wave when you finally meet it, you're going to go a lot further, a lot faster. It's going to be a much crazier circumstance under those conditions.
Well, I
But
wouldn't have to change much. I would just the piezo itself, where it's at, is perfect.
yeah,
All I need to do is make it high voltage leach now.
all right.
You know what I mean? So I can pull it in and get that state on that plate to be an AC state. That's it. That was the answer. By the way, I've been working on those stupid snubber circuits for a while because I had to build one for my number one coil on my Tesla coil because the thing constantly blows out those MOSFETs.
All right.
So I have to create it and dump the energy on that. I can take the total energy of all of it and dump it at once. It's so irritating because fields. Everybody talks about electrons. They don't realize what fields do.
Mm,
When you're dealing with a Tesla coil, your number one is not connected to your number two, so you always get energy, but you don't realize the compressed state. So what it does is it blows back onto the number one and goes out and kills all your MOSFETs and everything in your ZVS. Well, yeah, it sucks. But you're looking at it going, well, how did it do that? It's supposed to just be pulsing out. It's because there's a pressure state there and we're not realizing it. And where the energy comes back, it's got to flow somewhere. And you want a snubber. You want an energy bleed. You want the energy to pull over to a certain zone so it doesn't go back and mess with your circuits. That's one of the main failures in all this. That's why I've been working on that piece. But that's the exact answer I needed. I needed the extra energy boost. Now I have a place to pull it inside the system.
good point. Right? Doesn't it make you feel stupid though when you start to realize like as even like you run a wire, and you're going to put energy from point A to point B, right? So what happens when you put energy one side to the other, right? So all there's nothing. It has less to actually do with the energy you're putting in, and more to do with the relationship of the energy you're putting in and the matter you're putting in.
Oh my God.
So
So
through. You know
this
what I
is
mean? Because what it's doing is it's causing an excitation state of the electrons in the conductor, which is why it's conductive and why some things are conductive and other things are less so conductive, right? The same as not anything's a pure insulator because once you cross that threshold, what's that threshold? Well, that's the energy that it would take to cause excitation of those electrons because they're less free than the other ones. You see what I'm saying? So, yeah, this is what is deterministic of the conductive properties of matter. Then you say, okay, conductor, it's moving electrons back and forth, but they're still in structure. That's the key, right? You got to realize these electrons, they're not moving anywhere. They're just knocking into each other at certain rates and certain amounts.
well,
Um,
hold on. Let me just stop you there because in this whole project, if you add electrons to it, it's a disaster. That's one of the problems in energy states is when you add electrons, it's a disaster. It's a cluster F right away. Okay, look, energy flows in fields. As soon as you start saying electrons everywhere, it ruins it. And I'll explain why. Okay, because there's different pressure states. When you're in a DC electrical field, okay, under 900 volts, it's like water. Okay, it's like compressing water. That isn't an electron flow. That's compression of a fluid state. When you get above 900 volts, you're in a gaseous state. You are no longer compressing it the same way that you are in the fluid state. And this is not something that physics picks up on, not when you look at the Faraday equations and the way he does them. But excuse me, when you start looking at the Maxwell equations, but Faraday did it right. He built it in high voltage and he realized the compressionary state. Okay. The epsilon zero, whatever it was, it's that state. And then you get into a higher state on that, it's now gas and fluid in a plasma state. Okay. So I know you guys like to talk about electrons, but if you don't build them out in fields, then you won't understand the state correctly. For instance, they say that the magnetic field goes in a donut. Okay, just hear me out. You know how dumb that is? If you open and close a donut like this, what are you doing? You're basically putting heat into it, and you'll melt that wire. At 40 amps, that wire's trash. Okay, 14 gauge solid copper, it's trash. Okay, so that's not what's happening, and you do not have a field without the two combine. You have to have voltage and amperage combined with frequency in order for it to move. Okay, I'm sorry, you just do.
It's an
But
immensely
that's
good point.
electrons aren't in this factor.
Well, no. So, okay. So now here's where we would disagree a little bit. It's just maybe thinking about it in a little bit of a different way. You know, if you think of the electron as a high energy state of matter as opposed to energy, okay, you realize that. Okay, so here, think about it this way: when you break down um, something through like electrolysis, for instance. Okay, well, what are you actually doing?
Okay, hold on. Let's get back to the systems they're in. Please describe it in the systems they're in. So give me a DC voltage.
Okay,
Give me
okay,
a high
so no,
voltage.
okay, so let's talk about RAV then. That's fine. Or actually, you know what? We could even talk about short circuit. Let's talk about short circuit. All right, that's general enough. When you short a circuit, you know you could look at it a couple different ways. You know, you created too much heat, therefore the heat that you created broke down the phase of the matter and then broke the conductor, created the short. Right. That's one way to think about it. But there are other types of shorts that could occur over time, and things that aren't just pure phase change. Okay, such as dematerialization. So you know, and there's different chemical processes that make that occur too, because electrons are more again more of a chemical process than it is an electrical process. It just so happens to be the mechanism in which energy utilizes in order to most easily transfer because of its high energy potential state that it's in. So what I'm going with here is that when you strip the electrons from something, okay, okay, it's not that they don't have a use, okay, but they create shit banging into each other, which creates usually some type of mayhem. Now, the only way to really stabilize that out is to use a rotational vector, aka, you know, so you have to spin it, which then creates a magnetic component, which is what RAV does, which is kind of key to this. But what I'm getting at with this is the dematerialization, okay? Because once you strip the electrons from a molecule, well, it's no longer part of lattice. What do you see when you get this reaction? You see pitting of the material. That's what you see. Why do you see that? Because you've broken the bond, you've taken the electron and broken the ability of the atomic mass to hold onto the lattice. You see? That's where I'm going with this, is the breakdown of it. Because it breaks down into, guess what? It breaks down to nothing. Breaks down to basically fucking nothing. And
Yeah,
that's
but
sort of the point.
no, I'm not disagreeing with the way you describe that. But bouncing around between each other. Look, if the rap teaches you anything, and I'll just say it for what it is that electrons are built out in the actual field of energy that's building out in between each one of them. That's your electron. They're not the little balls that are on the outside. Okay, and it's not the conventional understanding in physics. It's the opposite. You know, but this is why when you destroy the electron in there, everything crumbles to shit because the only thing left is that little piece of mass, and even that goes back into the electron. So if you look at it as the electron's a state that goes on the outside, okay, and it creates a field, then you're just talking about field dynamics when you're talking about how energy flows around wires, not through them, because we're not having little balls doing butt bumps all the way till the end. You know what I mean? And then it just spits out. Okay. Energy doesn't pass through wires, it passes around them. Okay. And it's because of that. That's why there's no electrons in it. It's a field. We see it as a flowing field. Okay.
Mhm.
But you're seeing it as electron hitting an electron going around, right? And that's their high state, and that's what causes agitation. But that's not what it is. It's the you have in a DC system a confined state in there. You have a frequency and a voltage. You know what I mean,
And
and an amperage
okay,
in there.
the way to visualize it mentally kind of is the bumping situation. But what I will say is this, okay, like first of all, in superconductivity, okay, there's no bumping, okay, but yet it goes instant. So obviously, it's not that that's a mechanism. It's just a way to think about it. I mean, realistically, it's just a precursor, like a requisite that allows for the interaction of the the matter and the energy potential. That's sort of what it comes down to. It's able to be induced into a high energy state because it is in a high energy state already. Therefore, once it comes out of its own ambient equilibrium of its high energy state, because it has valence electrons that are available, okay, that excitation, okay, think about it as lighting up or flowing more like a gas if you want to. It doesn't matter what you think of it, the mechanism's the same. So the same as when you light up a tube of gas, right? The whole tube of gas lights up, like, and then it's connected end to end. And it's the same thing with the conductive surface as well, with how the energy is going to excitate that, it's conductive. It's putting into a state of excitation that can be transferred. Um, and again, it's problematic because it's losses. It's including matter. It's what happens when you bring energy into matter, and it's trying to, and it's creating its own equilibrium state. Those losses occur because it's creating its own equilibrium state. You see, the same as the hot air and the cold air in the room, and then the gray area in the middle. Well, the conductor in that case is just the gray area. Gray area. It's the conditions in which the transfer is able to occur. And that's sort of it. Like it just becomes interesting because of how they actually play a role in these. And it's like in my belief, at least, that you know it's the stealing of it's the breaking apart of that matter, from an electron and an atom. It's the breaking apart of that, that allows for these two differentials to occur. I mean, that's sort of my idea of it, and that's what allows the high energy potentials to gain in density. On the where the electrons are most dense, and then it's what allows for the depletion of a high energy state where there's just basically, atomic nuclei filling out like, okay, what now? I'm not doing anything.
Yeah, I think. Hold on. I think what you guys see as electrons is a gaseous state taking effects inside of a pressurized field. Okay, that's it. And I say that because we deal with the RAV and everything, and it goes into gas, and it goes into plasma, and it goes into like a fluid state. And I think that's just what the extra energy, the extra stuff that you guys are talking about. That's all that is to me. Because as soon as you break it into high voltage, that gaseous state starts coming out. Okay, and you start seeing it in high energy plasma. As soon as it starts coming out, you get that smell in the room and everything. It doesn't come out of nothing. It's always been there. It's always been there in the low voltage, except for it's not been amplified enough to show it. So I think what you guys are actually experiencing is a gaseous state starting to happen inside of the covering of the wire. The coating in between there, and it gives it a high pressure value, and it kind of changes and amplifies it a little bit. I don't I don't subscribe to the lectures. I kind of like more like Tesla, where I see the energy flowing, and I don't know how the hell you guys find these things. You know what I mean? Like, I understand that they wrote these things down. The guy gave an explanation for it. Okay. I could write a whole book on electricity and never mention an electron once unless I'm building out some kind of a field. And then a field is absolutely an electron.
Well, I think that they only really become relevant in terms of these exchange equations, like not equations, but these exchange circumstances. Okay, and you could write about electricity all day long, but at the end of the day, like what we're talking about is non-electrical in its ideology. It's much more fundamental than that. Um, it, I don't know, like the way that I kind of think about it is sort of like the whole reason that it exists in the first place is like it the electron becomes like the buffer between um, the the matter, which would be like an atomic nuclei, and the energy potential surrounding it. So, like, if it was like a game of chess, you'd have like a white, you know, pawn or whatever, and just like surrounding that entire pawn is all the black pieces. The thing can't move, right? So then it's just kind of in place, held in place in relationship to that behind it, and it's acting as the buffer of the energy getting to the atomic nuclei because it, it's sort of energy like so it's accepted by the energy, so it's not like they're trying to knock it off the board, um, but it prevents what we're causing, you see, generally. But when you take it away, then you can't prevent what you're causing. Now all of a sudden everything rushes in and that fucker runs away, you see, and now he's running away from it's just like that's what we're initiating is this chase is what I'm saying.
No,
um,
okay. Let me say it a different way. You know when the rat builds out and you build out that little ball, okay?
mhm,
And we talked about this when we talked about the worm that we saw, right?
mhm,
I think honestly it builds out because you have a leaky gas and it starts to go in there and starts to flow and it's going against the scalar that you're building out from the center of the valve. And when it hits that, it makes it turn and it makes it spin. And as soon as it spins, it creates its own flow in there and it starts to build plasma and everything else based on its compression rate. Okay. And I think that's exactly what's happening here. Okay. What I'm seeing is a little different than maybe what you're seeing is I think that's the way that they're built out. So anytime you do that, you have a potential for mass to accumulate if anything goes in that field. If anything like carbon goes into that field, it could intensify that amount of plasma and bring it into a solid state.
mhm.
Okay. That's what I'm thinking is going on here. And then you get the next one and it builds out, and then you have two of them built out on the outside of that, right? And it starts to give you different molecules and what's going on. Okay. It's not that I don't believe there's something there. I honestly believe it's more of a gaseous state. It's the conversion happening before it's ready to happen. It is what I'm seeing in it.
Yeah. Hold on. Yeah, John Bigman's on to something. So he's saying crystallized plasma. All right. So this is something that we've tapped on a little bit, and it goes right in line too with what we're talking about with the Graviflyer, because this would be kind of happening whether you like it or not once things are right. But when you separate this, right, like the atomic mass from whatever, I'm not even going to say electrons, from whatever the fuck it is that's not an electron, doesn't matter. Okay, for dating's sake. Um, once you have this loose atomic mass, that's just like pure mass potential. That's all it is. It's potential. At that point, right? You see it structuring on the other side from the high energy potential, where you see the plasma structuring. Well, why is the plasma structuring? Well, because the non-electrons are over there doing the dance in an ionized state, and that's what the plasma is. So when you actually bring the two together in um, certain operations of resonance, the same as the RAV forms a specific structure, and then the snow forms a specific structure on the other side, which is just loose atomic mass, which is why when you kill the power, it just goes away because why? Because there's no electrons holding it together. So if you have a reintroduction of the atomic mass and the non-electrons in an intermedium, in the gray zone, so to speak, and that gray zone is in a certain resonance that forms certain standing waves, then all of a sudden the structuring of the relationship between the atomic mass and the non-electrons, okay, would be deterministic of what you get out of that process as far as actual matter is concerned. And that's what I have to say on the subject. I'm sure Bernie would have plenty to say on this subject.
Oh yeah, well he popped in earlier. He popped back out.
Yeah, I
Hey,
saw. Quickest
right
appearance
here.
ever.
Just was yeah. We're past the hour mark, so I'm putting all this stuff up. Limited State says metals have been called crystallized plasma by many folks. Now think about that. All you're doing is changing the structure of everything, and it changes what material you're putting out. That's kind of, you know what? We haven't seen it happen yet, but I think we're going towards that. We've seen, okay, so I don't want to say this. I don't want to give away what stuff Sean's doing, but because we've seen it in other ways. So I'll just say it this way. We've seen the breakdown state. We see where something that had some sort of certain mass to it got broken down into like a carbon state or a carbon plus state or however you want to say it. Um, and we've seen the breakdown of stuff. And the other side of it was like you're saying is the cold side where it starts to do the snowflakes. So we've seen the accumulation of stuff to make something. So when the people talk transmutation, you know what I mean, and how the elements are actually working, I've only seen the hot energy state in which they started to destroy things and created the carbon state, right? And I've seen that everywhere. Okay. Bob talks about it all the time. I have yet to see too many people that pull out the other side of it and build the snowflake. You know what I mean? So,
Yeah, that's almost not heard of, by the way. Like, in fact, it's been seen almost exclusively in the most high-end laboratory,
yeah.
billion-dollar funded, research labs. That's where they see those results. You've seen it on this show from Sean. So that's happened. But the whole reason that it's on the other side is because it is the other side. You see, in order for matter to hold together, okay, it needs both the high energy and the low energy state. That is the attractive value between the two, which is why they do the chase. And if you just vector them and you put them into in different states, it becomes the game of cat and mouse where they chase to combine, but they don't. But if you create the gray zone for them to actually interact in a meaningful and controlled way, well, then they fall back into their state of equilibrium. And that state of equilibrium is matter, because matter is an entropy lock. And that's what I said earlier. Matter is an entropy lock. So everything that you see around you that is matter and everything that you don't, okay, is literally a hot and cold state in a gray zone of ambience. Among more ambient, and it's all dependent on its then external relationship with the energy fields around it. And that's what we've been saying all along about it. Maybe just not in those particular words, but it's an entropy trap because you could bang matter into other matter and transfer this energy all the time. That's what we know. And that's what entropy is. But what happens when you break down the matter into its parts and separate it? The entropy doesn't exist anymore because there's nothing to slam in. They're in a non-equilibrium state, and it
And
becomes
then
a
you're
super.
stealing the electron. I get
You're
it.
stealing you're stealing the electron. You have a mass. There's nothing to hold it together, but it wants to combine. But the way that you vector it, okay, and the states that you put it in, it's either going to combine in some kind of fashion or not at all. If you get it not at all, then you have a non-equilibrium state, and then all of a sudden, uh, we're again. That's when the weird stuff happens. Like, I mean, go into that's like observer effect stuff at that point. When you start doing non-equilibrium state, it's like, do you have observer effect? Chances are when you break the matter apart to a degree, you don't have observer effect.
Well, okay. Compression and energy is, oh my God, so much different in a laboratory than it is in open air. Okay. Let me just say this. Okay. And I've been watching Ashton's show for a while and he talks about the airplane, right? And it gets me in this simple way. it's open air. This is not a laboratory setting. So when you start taking attributes from a laboratory setting and start assigning them to open air, you fail. Okay. And you always want to make sure people understand this. It's a gaseous state. You're literally building in a gaseous state. Okay. In order to build in a gaseous state, you must realize it's a gaseous state, number one. Number two, if you don't realize you're dealing with scalar with the planet, and that's how you get your swirl, okay, you get that curl to happen, you have to realize that that's where it's happening. We see it in the RAV. As soon as the RAV builds out, you see the layering, okay? That's why it was so important to see the fields. As soon as we had it to amplify, you saw the fields coming in the outside. Why? Because it tells me exactly where that curl is going to happen. I can tell you exactly the line that those little balls are going to build out on. Why? Because I know exactly where the curl is of the scalar right there. Why? Because they change frequency. Soon as they change frequency, I know where the sheath zone is, okay? I know where the sheath zone is. I know where the leak is going to come from the gas. I know where it's going to form. And I can tell you exactly which molecule it is when it does it, okay? That's how I already know. It's already built out that way. So when we get into ball lightning, it works in the same exact way. We're dealing with scalar. We're dealing with open air. We know where the curl is. We know where the voltage is. We know where we need to have the two combined, the magnetic to the voltage, in order to get the curl to go into it, because that's all an AC flyback is. It's a magnetic with a high voltage potential on the top. They get to the curl and they spin, okay? They create that zone, okay? But that's what creates that little ball, okay? You don't have the balls that go around to create the zoning for that plane to go through without it, okay? That's what you have to realize, okay? Once you realize that, now you can dictate where they go. I can shoot a high energy laser to it and get it to curl. I can create that ball right there. Okay.
So
That's
like you just said, man, the layers where the frequency changes, those are exactly that's the skimming effect, and it's what we discussed before, where you have this interesting circumstance that occurs where there's acting barriers between resonant layers, and the in the zone of interaction is not gray. You see, there's no mixing. Okay, it's because of the torsion. Okay, the torsion leads to laminosity of the layer. Okay, which keeps it under like more or less surface tension. Okay, there's more or less surface tension, and that surface tension against other surface tension of a resonant factor, okay, actually does not have any loss or friction between it. Okay, but they glide right on top of each other, despite them being at different rates and different densities, because they're in resonance, but they're also laminar and in relationship. So you have this interesting relationship that occurs at these boundary zones, you know, where the zones are literally touching, but rolling off of each other. Okay, and that rolling off of each other actually it does not take away anything from either zone. In fact, if anything, it just further stabilizes the motion, like two rollers, you know, spinning against each other. It's no different. You know, and that's sort of you know what's going to happen between the different fields building out in a UAP, is you need those zones to build out, compress and roll. And once they're compressing and rolling, well, what's that mean? That means that that outer layer, like I said, right, it's got to make its way through. That last zone has to make its way through. It's got to come up, but then come back down, to come back up again, to come back down. It's rolling. And it just can't be lost into diffusion of the atmosphere to nothing, or else your differentials are gone. And that's the same thing with the RAV. You see, if the RAV didn't do that and have those torsion zones and build out in those layers, therefore adding to the stability, it would just be a diffuse state like everything else. It would be no different than welding at that point, which is what you see when these, you know, when the non-equilibrium state is not achieved through that same type of relationship, right? Because there's still an anode-cathode relationship that exists in welding. Yet a welding arc does not form a ball of plasma in which does not leak its heat or light. Like that's just not what it does. Nor do you get fractal snow forming on the other side of whatever metal you're welding. These things don't happen, right? Um, and that happens to be why. So it's really critical to realize that. I feel like it's all just about this rolling containment. It's the figure eight, the infinity situation. It's just repeating on multiple different scales all over the place. But that figure eight is exactly what's going on everywhere you look. Um, which is kind of interesting because the figure eight is the one vector of electromagnetism that we don't define. You see that? Because it is neither in a pure current state or magnetic state. It's somewhere in this intermedium.
Hmm.
Does that make sense?
Uh-huh. You know, let me say this, Joe, because I think it needs to be said. Ancient cultures wrote this all over the place, and we fail to understand it. Maxwell himself did it. Okay, check this out. Okay, he did a round circle, put ball bearings in it, another round circle, ball bearings, put another round circle in it, right? What experiment does that sound like to you?
Yeah.
No, okay, I want to say this. Okay, I could never say the damn thing right. Okay, they spin those pieces of copper around and they put it around these discs, right? And they're doing it in one state, okay, in the center, and then they build it out to the next one, right, and the next one, and they're wondering why it has anti-gravity properties to it, right? Oh man, I can't think of the name of this thing. I'm sure somebody in the chat will tell me.
Oh, what's
Okay,
up, guys? I don't know what he's talking about.
it okay. Anyway, the serial device. I always want to call it the serial device, but it's a serial device. Okay. Do you know why it's working that way? Let me clue people in because they don't understand it. You are literally building three lines of frequency that, based on the material that you're using, you're rotating different values in there. Okay, you're rotating a sheath zone. You're rotating a high energy state. Okay, of like static in there. You're also rotating a magnetic state. Okay. And then what are you doing on the outside? It's basically just like the RAV. You're creating plasmoid states, which are the rollers, okay, that they put in between them. You're doing the exact same thing. You're just doing it in a mechanical form. Once you do it in the mechanical form, you have to realize that you're going to get the same answer that you get in anti-gravity. It's going to create the same thing. If you only create the center, you're fucked. You didn't create the rest of it. Okay.
Yep.
You didn't understand it properly. You need three fields. It must build out that way. Okay. In order to understand that, when people just do it and they see it in a simple mechanical and oh, everything's magnetism. Dude, you have failed. You have completely failed yourself. Okay. You didn't understand the states of energy properly. Okay. You didn't understand that entropy is always in there. You didn't understand radiation has always been in there. You didn't understand that they build out in gaseous states, fluid states, and then go into a plasma state. You didn't realize any of that. Okay.
Yep.
And you built this device based on the mechanical form. You have absolutely failed to understand it properly. Therefore, it will not give you what you're looking for in it. Okay. The RAV is a perfect blueprint of exactly how things built out.
It really is.
Yeah, so you go to the ancient cultures, what do you see? Oh, they have these circles here, and it, you know what I mean? It looks like a dartboard, and we're doing this, right? And then you go, okay, then you go to the next thing right next to it, there's a swirl, it's doing the swirl, okay? And then it's telling you, oh, by the way, everything's mirrored, so everything must be in the opposite, right? But how do you mirror a dartboard? Well, you put it in 360-degree form, okay? They're telling you this in every single part of the world, right? Hey, geniuses, we've already figured it out. It's already done. It's already here, okay?
Oh man, I was gonna say that you take a picture of it with your frontward facing camera, but you're smarter than me, man. I don't know. Mirror dartboard. Anyway.
Well, I'm just trying to say, I mean, it's been written everywhere and people refuse to understand it because they don't understand what the initial structure is, okay? When we say atoms, it's not any different than when you're building out an atom to a RAV, okay? What's the actual difference? You're dealing with the frequency difference. If I bring the frequency way down, guess what happens? I make that RAV smaller. Okay. If I bring the frequency up, I make the RAV bigger. That's about as simple as it gets. Okay. Now I can amplify it in different ways and make it push out the energy in different ways, but all I have to do is change the frequency. So when I get to a very low frequency, it makes a very small RAV. Okay. When I get to a very large frequency, it makes a very big RAV. Okay. Why? Because they have less area around it. Okay.
Mhm.
It has to do with the compression of it.
It
And
definitely has to do with the compression. Yeah.
yeah, that's it. I mean, so whether it's super small or super big, we're not talking much difference in it, but the result will become different because it builds out in different ways with different things together. They combine differently. Okay. There's that's why you got to get into diffuse and non-diffuse zones. You got to get into the entropy of it. You know what I mean? Which has more, which has less. That all matters when you build out this stuff in the way it is, man. I'm telling you, it's all the same.
Yeah.
People,
You sound
it,
like
it,
me, man. Yo,
yeah, it's all
diffuse,
the
not
same.
diffuse, it's all the
People,
same. Yo,
dude,
I must have rubbed off on this man. Holy shit. Hold
dude.
on. Before we go crazy, Rand, I just want to give a big shout out to Victor Sears. I just want to say it's good to see you in the chat, man. We miss you.
Oh,
And
Victor Sears is here.
he is, and Brandon's here too. You know, it's like everything's coming back
Oh,
together. So good to see
nice,
you guys. Been a long time no see.
dude. Shout out to both of you guys, man. I miss you both. Those guys are awesome.
Yeah, I was trying to cut off your rant several times to give that shout out, but I just let
Oh,
you know, man, cook, go for it. That's what the show's about.
man, yeah, right on, brother. Yeah, we miss Victor, man. I love it. I know things I didn't know I knew. I love that quote.
Never get old, man. The
Dude,
best.
he gets me every time with that one. Every time I watch that back, man,
But you
love
want to
it.
know something? That is by far one of the most intelligent things that you say, because like that tends to be the theme of every episode Nathan and I have, is we're like we're always like, and you won't believe it. Oh, I can't believe I just realized this. I've known it all along. Holy shit. And it's like
Yeah,
it's just the application of everything's the same. Just keep on applying, everything's the same. And then it eventually starts to unfold, but then it just opens up more doors, doesn't it? It's just a crazy way, man. But yeah, we miss you, Victor, and it's good to see you in the chat, man. And
absolutely.
Brandon, of course, you know.
Yeah, right on, man. This is so cool.
Yeah, Brandon got whipped, bro.
Freddie got a girlfriend and he straightened
Brandon
out and
got
stopped
whipped.
listening to us.
Brandon got whipped.
Oh, that's so funny, man. Oh man, you know, I say that joke because I always I'm like everybody else, man. I love ancient structures and stuff like that. You know, what I mean, we look into this stuff. I mean, how many times did I have to see it in the road to really understand it? When you start building it, you're going, "Oh my god, are you serious?" Like, I built this before, right? So I built this field bubble on the Graviflyer a year and a half ago. Okay, and I'm going, okay, here it is. And how do I get to show it? And I could never figure out how to show it. And then I couldn't tie in the directional to it to get it to amplify in one direction, right? Biggest problem I ever had. And I think we've now solved why, okay, throughout the discussion here today. But it also tells me about everything else. I already knew the answer for where the RAV was going to go because I've already built it. It's the same goddamn thing I built before. You know what I mean? I knew what it was going to do. I knew which one was going to interact. It's just irritating, man, when you don't, you know what I mean? You didn't have that final piece of the puzzle to put it together. And we've been talking about this for years.
Oh, I love every time I look over to the chat and I get to smile about something, dude, because Victor hasn't been here in like almost a year. Okay, and he's coming in hot.
Oh, yeah,
Let's
it
watch
is.
the flavor later. Proves out ether control. So hold on. Let's dissect this just slightly more. Okay, what I was saying earlier, right? So you have all this ambient nonsense, blah blah blah. You know, now you're creating diffuse and focused energy in certain ratios, and then you're bringing them together, and then they're playing and chasing and forming all the different vectoring of the electromodes of energy, and then all of a sudden it starts breaking your ambient environment down into, this high energy state, this low energy state, and vice versa, by the way, right? We know that that's the exchange. And then, what does that mean for the ambient environment? What's left? If you're breaking down everything into its constituent pieces and then pulling them into zones and then having them self-organize, but your field effect is whatever it is, right? Well, what does that mean is left once you take the you're not taking the matter out, right? You're just changing it into these constituent states. But what you're left with is pure energy potential at that point, aren't you?
Oh,
Like, because
yeah.
once you remove all the nonsense out of it and then you get close to the superconductive state, now all of a sudden you've opened up that entire area that was the ambient area into now, and a pure potential state that is now being only and solely held open, but also influenced by the exchange of what you have separated. So it's a really good point. Yes, that's a theory of control. And that's what I was saying before about if you are able to control and modulate the resonance of a gray interactive zone between your separated differentials, how you can actually start accumulating matter in that space, like because you have that control over the environment at that point. You're able to take all the bits and pieces of what makes up reality and bring it back together in
Well,
your own form. Yeah.
okay. Let me just say it like this. Okay, if you look at little gas bubbles, okay, in the air, and you say, okay, it directly plays with entropy, right? Because as soon as those things spread out, right, you have the high entropy state. Okay, but that's where high voltage lives. Okay, as soon as you combine them back together and you have a low entropy state, that's where magnetism lives. Okay, so I use gas as a medium there just so you can see it a little better. Compress the gas, you get to plasma. You don't compress the gas, you get to an open state. The problem with what everybody misunderstands and how gravity works is you didn't understand how T.T. Brown actually was looking for stuff in high voltage states. You see, you get the anode and cathode effect, but what did he do? He stretched them out. Okay. He wanted the zone in between them where it looked like nothing was going on because that's the zone we're in right now. So as soon as he can interact with that zone, it was game over. He could do whatever the hell he wanted. Okay.
Mm-hmm.
The problem is that's not the way people are setting up the experiment. They start seeing it as, oh my God, you got to have ion wind. They're misunderstanding ionization and an ion wind. Two totally different things, okay?
Oh
When it
yeah.
comes to how things work and how things structure and build things and break them apart. So if you really want to understand it and get it right, it's that state between here and here where it looks like nothing's here, okay? That's the state you have to understand. If you can control that state to move up and down, you have the world at your knees, okay?
Well,
It,
or place it in multiple points through again standing wave modulation.
yeah, but
Then you're creating nodes. That's the
but you
ladder structure, man. That's
but
how
you
it goes.
understand what I'm getting at here, right? They're looking in the wrong place.
Oh
They're
wow, please all day
they're thinking it's a flow from top to bottom, and that's the way you need to look at it. But that's
like this,
not. Yeah,
huh?
yeah, they're doing that a lot. Yeah, they're not understanding the true meaning of what T.T. Brown was trying to tell you.
Yeah, it's
So,
true. Well, there's somebody other than us that did something similar than us. I'm not even saying this right. Somebody has a video out there, okay, where they were doing something that emulates somewhat what we're doing, except from what I can tell, the ratios are off. Okay, but they're still getting something that they don't know what it is. They think it's something else. If you listen to them, is that they think it's something else. But they're
oh,
getting a similar result. They're just not taking it far enough. And what that experiment showed was an anode and a cathode, tungsten anode and cathode, just basically in a spinning barrel
oh
uh,
yeah, I saw that
full
one.
of carbon, yeah, full of carbon coke, and they were basically breaking the carbon off the hydrocarbon chains of the coke, and it was breaking it into graphene. And they were like thinking that they were doing it just because they were putting it inside of an arc. But that's because they're not seeing what is kind of forming underneath inside the coke. Because what you'll notice is that after it spins around and starts breaking down and stuff, right? The coke is playing this role of this intermediate, and it has moments of correct proportionality between the anode and the cathode. Okay, and then all of a sudden it'll go super bright in a spot without shining out to any other spot. And I know that. I know what does that. But then it'll turn and it'll collapse because natively their anode and the cathode isn't in the correct configuration or a ratio relationship with one another in order to predictably and controllably form a graph. Okay, but they spin this thing around and around, and after 2 hours, they get what they consider to be a substantial amount of
There was like that much.
graphene, and it is very, very little. Okay, now it, obviously in graphene production, that's pretty significant. Okay, however, um, I have a hunch that the reason that they don't have a much higher yield is because they are not maintaining a RAV. You see, if they maintained a RAV and had that as their intermedium, I think that they would be creating graphene at a much higher rate. I think that it's only producing when it's in that RAV state, because when you see it flashing out, which is just like kind of sporadic
It
too,
starts to build it, yeah.
it's not in resonance, it's not building, it's not forming, it's going into a state of existing and then collapsing. And I think it's only forming small amounts anytime the RAV actually manages to form, once the ratio is correct, depending on what's in between the anode and the cathode, because it's constantly changing because they're spinning this bucket around. That was their idea. Rather than spin the bucket, they probably would have been better off distancing the anode and the cathode, and then putting a barrier in between them, and then just arranging the coke in a way, or whatever, arranging the coke in the way that it forms, and then it'll form its channel, and through the channel it'll sit there and blow deposits out its rear end, like you saw in Nathan's clay a million years ago. And that little deposit that you had was probably a large portion of what they created mass wise altogether. I'm not saying that was graphene, okay, but I'm saying that, I mean, if you had the right constituents, then it could be, right?
Well, yeah, but you do realize a simple rotational state for that was to, how would I say it, put the metal plate underneath the pot. You know what I mean?
Mhm.
Instead of what they were doing, and then it would have became the cathode effect, right?
Exactly.
And then they could do multiple whatever they wanted and have it spin, and then they would have got a higher value. Yeah.
Ironically, if what Nathan just said, if they would have put a metal plate, charged the whole metal plate, made sure that the metal plate was greater mass than that of the anode, and then actually rotated the anode, they probably would have had the ideal result.
Oh
And
yeah.
if they would have broken down the coke into like powder as opposed to the rock, so it was just running along the powder, I mean, probably would have gotten really good yield results out of that. But you know what? Maybe they'll watch this video and send us a check.
Well, you know what? Maybe I'd be honest with you, Joe. I'd put maybe little holes in the side and the bottom and let it flow out, build up, and then push it back in. You know what I mean? And rotate it through, make sure it is properly broke down.
Mhm.
So yeah, because you get a higher yield out of that by going back through it.
Well, you got to
'Cause-
remember, graphene's so fine. It's basically a single like molecule, So all you have to do is put a very, very fine mesh at the bottom,
there you
and
go.
then the stuff would come right out, wouldn't it? Yeah, you could grind it fine as dust and still have it, come out the bottom, because of, no screen is going to stop a single molecule.
Hmm. I'd be interested to see what they go to the next level, if they would take advice on that in order to change it a little bit to get that state in there and then get more graphene, because anybody gets more graphene is making some money. You know what I mean? I think some of the stuff that we do in the RAV, we can make graphene fairly easy because we're structuring the carbon in the cathode state all the time.
Well, okay,
And
so here's the thing: you don't even need the high efficiency for the RAV to do that, because everything that we've said is 3 steps ahead of that already. Like if you've already broken it down to its atomic state, okay, that you are far more efficient than breaking it down to its molecular state. You see what I mean? Like it
Mhm.
doesn't need to run at super high efficiency. It just needs to do what it does with the, you know, pulling shit apart and then throwing it back together real quick. Like you don't want things to be falling on huge distances and stuff. You just want it to happen intermediate inside the coke where it does the exchange, where the fields cross at that one point. So all these fields they're multiplied. There's a magnetic field of like, and I know you're like, oh, not magnetism. Well, we know that there's a magnetic component to all this that kind of exists here or there in one way, shape, or form. There, there's a magnetic component on the RAV side. There's a magnetic component on the other side too. You see it as an individual magnetic component, but those are crisscrossing, interfeeding, dual toroidal, counterflowing like geometry. You see what I mean? It's like it is the infinity sign if it was two toruses counterfeiting into each other. This is
Mm.
what that does. So you need that cross point of those two magnetic components, to smash it back together, but only at that molecular level. Because once they come back together at that molecular level, then that's what falls out as a single molecule of carbon, which is graphene.
You know, it'd
It's
be
its
funny,
own thing,
Joe.
you know?
It'd be funny if you literally had plates that things sit on, and then you get a high how do I say it, a high cathode value, I think, in them, and you ran in grooves just a little pot, the clay material, it already set out in the structure that you want, right? And then you just ran the anode over it. Okay, kind of like you're welding, right? But instead of welding, you're building the RAV, and the RAV does move as you move the anode. You know what I mean? So you
Mhm.
could literally go all the way down and have this whole just line of graphene already built for you, already in the structure, already set. There's
Now,
a
I will
way
say
there.
it's wildly hydrophobic. Those black dots that form on the surface of whatever the intermedium is, of the membrane surface, like that black dot. No, what you can put water on it, it'll go right off, like, and suck right into everything porous around it.
Yeah. All right. Hey, I want to give a shout out right now to the Traveling Fools channel, man. They have a big show going on tonight. I'm going to be there with them. Um, we're going to talk about James, okay, and his I don't know what you want to call it, his UAP device. Um, going to be a big show, man. Everybody over there is excited, man.
That's really cool.
Dude, we talked about it last Monday. Did you catch part of it, Joe?
I did, yeah. Well, let me tell you what I think real quick.
No, could you go for it?
I think James is lying.
Really? Lying about it being a
Exactly.
hoax?
Exactly. No matter which, either way, I'm right. See what I mean?
Oh, come on now. I thought you had like a good point to make on it. I'm
That
like,
is a
what?
good point to make, isn't it? I think James is lying. Lying about what? I don't know, but he's lying.
Oh man. You got me there for a minute, Joe. No, because he showed the big rod, right? He came out and just did a live a little while ago, and he showed the big rod, and it looked. I'm sorry, but it wasn't shiny or anything, and it looked dull. And he's saying it's the original rod, and it was quite big, and he didn't show himself doing that. Uh, anyway, and everybody's in there going, "No, it's fake! It's fake! It's the wrong one. That's not the same thing." I just, dude, so many things around that guy is just hilarious in the
I
stuff
mean,
that he does.
honestly, though, like, what, fake it, not fake it, whatever. It doesn't matter. I mean, he really should have tried to stroke it like that because, I mean, if anything was going to make it take off, it'd be that. For scientific purposes, okay? For scientific purposes.
You want them to lather it down for scientific purposes to shine it up.
Exactly.
Oh man, there's so many people. I read the chat. There's so many people in there, Joe, that still believes that he's been copied or replaced, or he was abducted and replaced, or that's not the same Rod that the government got to him and he's covering things up.
This is what I'm saying. This is why disclosure can't happen. Okay, is because unfortunately, when people are absolutely positively full of shit, okay, and they lie for so long, they could come out and say the truth, and you still wouldn't believe them, and that's the problem. And that was exactly the point of my joke. Like, what do I think? I think he's lying about what I don't know.
Probably
Like he,
everything.
right? He was either lying about the thing, or now he's lying about the thing. One of the other. You can't say two polar opposites of things, and this is why the government gets away with the things that they do. All the time.
Oh
This
my
is why
God, dude.
everything's a conspiracy theory.
I'll say this, dude. I am not mad of him in any way. I think what he did is hilarious. Either way it turns out, okay? We've had fun on this show with poking fun on it and with believing a little bit, you know what I mean, to go through the stuff on there. Dude, I've had a good time with it. And honestly, whatever way it came out in the end was good with me, man. I'd have him on the show any day of the week. You know what I mean? It's just amazing what people believe right out of the gate.
I know,
And
man.
then what people continue to believe when he tells you to your face, you suck, I hate you, and like, you know what I mean? You guys are stupid for giving me money. And it's like, okay. And then people give him more money. And I'm like, oh my God, dude, I must not understand reality perfectly because I don't get that. I
Yeah,
usually get hate mail.
I mean, as they say, it's all fun and games until a 400-pound guy in a wife beater and flip flops and an RV shows up at your house and throws a bag over your head, and he's like, "Show me the spear," you know what I mean? And it's like, "Oh fuck, what did I get myself into?" It's a lie, bro. Did you see the writing on it? Like just let me go. Yeah, it's like whatever.
Oh my God, dude. He That's what makes it even better. Dude. Oh man. No, he literally yeah, he literally showed that thing. It was not the shiny same rod. I don't know what the hell. And it's dude, it was light. So he said it was basically a hollow tube and then they welded ends onto it, which would make a lot more sense at 28 pounds. Because it would normally be like 50 or 60. So that made a lot more sense. But it almost sounded like a hollow tube as he was throwing it around, and it looked dull. So
Yeah.
and when you get to stainless steel or whatever it is, it almost like chrome. I don't think it should be dull at all.
Yeah, I mean, listen, let's say I found one of those things, what would I do with it? Well, I'd probably paint it black and get some truck nuts and then hang it on my wall. That's what I would do.
Joe would be on OnlyFans. Okay, let's not lie to each other. Joe would have an OnlyFans account if he had this thing.
Who's that's? Not mine.
Hold on, let me just share this real quick, dude, because I think it's freaking hilarious. So here he is. Look at how dull that thing is.
Yeah, it's very black.
And you can see the writing on it. There's no question there's writing on it.
Can't see anything, Nathan. That was a joke. It's a black screen.
Oh, sorry. We can't see anything.
Yeah.
Oh, wow. Well, that's a screw up. Here I am, and it shows it.
It's plain StreamYard like everybody else.
Well, that's not good. Can you see it now? Now we see it. Okay, there we go. They finally allowed us to show the rod. Okay.
Well, now I
YouTube
now I
blockers.
know why he never showed his face until now.
That isn't nice, Joe.
I'm not nice. I mean, not at least not all the time. Sometimes I
No, look at how dull his rod is.
Anything else, Nathan?
Yeah, it looks like it's like painted instead of polished.
First of all, did you see the shape of his head? Clearly, he's a gray alien. Okay.
He's a gray alien with a mask on.
I've never seen anybody with such a wide temple and narrow jaw in my entire life.
Oh my. You're funny, Joe.
Okay, come beat me up.
All right, let's get past that, dude. I'll be honest with you. It does not look like to appear to be the same rod.
Yeah, no, that the other one was very shiny. Yeah, it was. Yeah, that does look kind of aluminum-y, I'd have to say.
Faraday says it's a intergalactic suppository.
I mean, seriously, he's holding that thing with one hand. If it was stainless steel, I'm not certain that man could.
Yeah, I'm leaning towards a different rod, man. I mean, I don't think you could depolish it that much. I mean, look, that looks like he's stealing it.
I can't. Honestly, good for him. Yeah, listen, I love it. I think it was a great joke. Yes, I made fun of you a little bit, but it's all in good humor, and either you're down with that or you're not. Put on some shoes if you're in the basement. And aside from that, man, like, good on you. A little hoax in here and there doesn't hurt.
Oh, dude, yeah, no, I agree with you, man. It's still going on. I don't think it's going to go anywhere, Joe. Not for another week.
I didn't buy it from day one, so I don't know.
He said it's pre-polishing.
Okay.
Maybe, yeah. But then he wouldn't be talking shit on the channel when he did it. You know what I mean? Because he was talking some smack there too. So I don't know, man. Maybe it was used at this point, and they haven't cleaned it back up.
You're gonna wipe the lube off of it.
God, that thing looks big next to him.
Yeah, you're not kidding. I mean, he only said it's 5 inches in diameter, for Christ's sakes.
Jesus. That's like a monster, dude. If that was on OnlyFans, oh my god, dude, that's insane.
Yeah, he's a horse or a cow or something.
Yeah, he teased, by the way, when he was talking crap to everybody, when he came out and said it's a hoax, he said, "Oh, yeah, I'm going to start an OnlyFans." I should have clipped that little portion for him and just put it on a short, because that would be hilarious with this picture.
Are you not kidding?
Oh my god. Oh.
You're right.
All right, let's see.
James and the silver rod.
Dude, I bet you he'd get a ton of money. He could just sit there with it, you know what I mean? And then girls play with it, and he would be all right.
Yeah,
he'd probably make all kinds of money.
Right on. They could dress up in cosplay and stuff. Make it all fun.
Okay, hold on. He's going to show you the tip of it. Let's see the tip of his rod. Look.
Oh boy, here we go. You have to blur it out.
Oh, hiding it from us. Oh, I should just hit play. Okay.
Skeptical.
Oh man, that thing sounds hollow.
There's the end, guys, if you want to see it clearly.
Well, there's the end of it.
Give you a full 360 around it. This side too. Yeah. I guess that's all we really have today.
Anyway, yeah, it sounded real hollow.
I don't know. Like I said, the only thing I know is that he's full of shit. That's the only thing I know. And no matter what, I'm right. I love that. Very infrequently do I get to say that either way I'm right.
Oh, yeah. I mean, hats off to you, James. Good job, buddy.
Yeah, listen, man, you pulled the fast one on someone.
Yeah, you pissed everybody off and made everybody happy at the same time, and then turned around and gave them suspicion again. I mean, that's an incredible turn for all of it.
You know what I do love, though, and this is credit where credit's due, but it's also like kind of dumping on a whole handful of other people simultaneously, is at least when we look at these things, we look at it from like, an entertainment perspective, but also from like we're scrutinizing it perspective. Like, okay, well, I mean, what could this be? What could be there, if anything, right? Is it, try to humor it, see what comes back, and humor it for what it's worth. Take it with a grain of salt. But uh, there's these other channels and stuff that all they do is this UFO and UAP stuff, and all they do is basically echo chamber, any single thing on the subject that comes up. And man, they ran with this thing fast and hard, like fast and hard. They were like, look at here, it's in his hand, it's real, it's there, it's in his basement, he's got it. And I'm sitting there like, my God, do you really like, I mean, what would you do for a click and a view, man? Like, do you actually believe this? Or are you just being totally unscrupulous, like, and
Oh yeah.
it's like I'd love to believe that they're just being totally unscrupulous and they're like, yeah, whatever, man. I have a UFO channel. I'm going with it. Like if it's, I'm believing it all, for the sake of the channel. Like if they actually believe that shit, like I mean, I don't know. I don't
Hey,
know. That's no disrespect.
somebody was mocking him and built a butt plug with alien writing on it out of metal.
Was it made of organite?
It was not organ.
No. Okay.
No.
Oh no. That's right. Those actually probably work. Not. I'm not saying that I'm down with that or anything, but like from what my understanding is, that
They
works.
put rocks up their ass. It must
Yeah,
work.
right. The Chinese that didn't put. Well, don't you know that the ancient Chinese have been sticking rocks up their ass for millennia? Well, no, sinner, I did not know that.
No, nobody knew that. Like who knows that? Oh my God, dude.
Well, did you know that in the 1700s and stuff, right? Like when medicine was like, they didn't even really know about germs or anything, right? And the doctors used to like basically just be like a bunch of quacks and coming up with whatever they think, right? So they used to uh, like get regular enemas back in the day, right? And like depending on your class of person that you were, depended on how frequently and what type of enema you'd receive, and it became like very prestigious if you were like one of these upper classes and stuff to like get some kind of magic tea potion made of like herbs and medicinal stuff and squirt that up your ass and poop it out or whatever you do and like they derive great pleasure for this. In fact, I believe for a while they even did that recreationally, and then a lot of trade was happening with North America during that time, and as you know, tobacco comes from North America. So one of these quacky doctors, he got this idea rather than blowing like the tea leaves up someone's ass, that they were gonna like take a pull from a pipe. First of all, don't smoke out of that pipe after that. But whatever. I digress. You pull from a pipe into the enema and then blow it up rich people's ass. And the thing about nicotine in tobacco is that it's really really addictive. So you'd have all these people fucking begging the doctor to come back. I'm a doc. I need the enema. I need the enema. And it's like, and he's like, "Oh yeah, is it working for you?" And they're like, "Yes, it works excellent. Please blow, please,
They're all addicted to their ass.
so please blow this smoke up my ass." You know what I mean? And that's where the old saying comes from: getting smoke blown up your ass. Is
Oh my
that literally
God,
the doctors knew it wasn't fucking helping anybody, but it never stopped them from sending them a bill.
dude! How how, ma-
That was it.
how many fucking cultures shove things up their ass for good luck? I mean, what the hell's going on around here?
The Chinese and the Brits.
Oh my God, dude, that's so
Probably,
bad.
probably the Germans too. If you've ever seen them, they're weird.
Oh,
they're into some weird shit.
I don't even want to know, man. I don't even want to know. They're still giving coffee enemas to rich people.
No, yeah,
I'm surprised Starbucks hasn't offered it yet. You know what I
okay.
mean? The low calf latte in your rear. They just
for real. The Illuminati getting baby blood enemas and stuff, you know? It's like having your period and diarrhea at the same time.
God, that's terrible. Oh, yeah. Oh, I saw that one thing. What did they bring up? Caterpillar prison or whatever it was called, dude. They had their mouths sewn to other people's butts.
Oh,
And
bro, that was the most messed up movie ever. Like,
one guy
never,
ate, the rest of them ate the poo.
right, never did you pray to be first in line so bad. You know?
Human centipede. Oh my god, dude.
Yo, that movie was grotesque. But it was a dumpster fire. You couldn't help but sit there and be like, oh wow.
Oh my god, dude. I just saw the front cover for it. I didn't see the whole movie. I didn't watch it, dude. I just saw that and I go, okay, I've seen enough. I don't know that I could deal with that. Like, what kind of sick depraved person does that? Then they have a whole freaking prison full of it in part 2. I mean, oh god, that's serving hard time right there.
Oh yeah.
Because,
I'm just like, I'm sorry you shut me up because now I'm just like sitting there like, oh yeah. Oh, I remember that. God damn it.
yeah, well, you know what? It was cool today, Joe, because we got to figure out a lot of things about that Graviflyer, man. I'm gonna strip out that center plate and get a working outside to it. You know what I mean? Something structure so we can put everything on.
Yeah.
I've been working on it on my CAD for a while now, and I think I'm just getting close to it. You print out some parts and then go for it. I don't think we made any major changes as of yet. You know what I mean, to what we need to do. Um, the motors, the discs are good. And then we'll just remove some of the garbage from it. You know what
Yeah. I
I mean?
mean, realistically, funny enough to build it. I just think that it's I think it's like a double array. I think it's like, you know, like how you have a 2 RAV circumstance, right? You actually have 2 anodes, 2 cathodes, and then you have a medium of interaction where it does not form 2 RAVs, but rather 1 RAV. And you have 4 components pressing in, you know, creating zones. I think that that's sort of it. And then the zones will split out and have equatorial planes. So you'll go from 4 to 8. You know, and that would actually create inverse eddy currents and then charge up the interior of the shell that has to be like good mass aluminum to press it in, you know, and also would allow some of the scalar component to press out and then it'll collapse and just form static on the outside and get drawn back in. And that'll give an external flow. That's what I think. I think it's path of least resistance. I don't think that there's moving parts. I think that it's just a matter of creating the right condition in the center. And frankly, the one thing I've been saying from day one, and I truly believe this because it's a little weird and whatever, I think that if you were to have your intermedium point of interaction be a piezoelectric, so if you were to get a crystal ball, for instance, that maybe was hollow in the middle and had your anode cathode situations going into it from opposite directions, right? Like top, bottom, side, side. Then you would actually have a form in the middle. All the field geometries would align outside of it because of it. And then you would just hook your cathodes up to the structure of the craft. Okay, that would create the greater mass for the diffusion. That's what I think. So your anode would be energy source, low mass, high energy concentration, and then your cathodes would run um, connected to the entire outside of the craft. Okay, so then it would be separating of the differentials on another even layer. You see? That's what I think. I think that doing that, it actually solves most of the problems and all the field geometries. And then also allows for the component of the cathode to go out to the outside. You got the escaping radiant, like I said, would go out and then be drawn back in because of the same exact mechanism that creates the RAV in the first place. You see? It would go through the material and then turn back around. It would return.
We're
So
going to have to create a couple side experiments during this thing just to see if each one works out.
yeah,
I see that because just putting them on there every time probably, if I had a lot of money, it'd probably work perfect. But I don't see that happening.
yeah.
I have the craft. You know, I got 2 Graviflyers, and then I'll build this one out. I already have the stuff for it. So, yeah, we'll do that first, and then we'll do some side experiments, see what need to be added to it.
I mean, honestly, maybe if like quartz is out of the question because of what it is, even just like a glass sphere that you can close off, you probably have to have it aiming, though something has to be centric of the glass sphere that everything has to be hitting.
I
So
have a
you probably want some kind of intermediate.
glass sphere.
So if you
I
have a
have.
glass sphere, I think, you know,
Got one about this size. I can get a smaller one.
yeah, you either going through the sides, you know, or whatever, one on the side, one on the top and bottom. Or, I don't know what the better configuration would be. But I think something like that would probably be good with how it builds out.
Hmm. I just want to answer this. Are you guys making a UAP? Yes, we are. I've been working on the Graviflyer for, God, what was it, 2 years now?
Years, yeah.
Yeah, somewhere around there. And then now we're bringing it to the next level. We got a lot of good things that came out of it. Unfortunately, it didn't work out that it would fly around like we'd all wanted to. So we're going to have to modify and go from there. So
Yeah, but you know, all this sidebar testing that seemed irrelevant to the Graviflyer, you know, we've been saying since day one, it ties back into that at the most fundamental ways. But all this other stuff had to be worked out, you know, in order to get to the point where you can reconfigure it because the Graviflyer is on solid state.
yeah, yeah, we didn't know it all because it's all groundbreaking science that nobody's
Right,
ever done.
that's right.
Yeah. I mean, who knew all this from the beginning? Nobody did. So we had to uncover every detail of everything. And thankfully, you know what I mean? We had a long list of good experiments to get there. I mean, we had the water test. We understood the radiation with the Tesla coil. We have the RAV in there, man. We did the coils and coils, so we know that. I played with the high voltage extensively to know exactly where everything is. I mean, it took a lot to understand to get here.
Well, I mean, and you know what? I want to bring something up, and not only because I don't know if he's still watching, but Brandon, you know, like one thing that actually didn't mean a lot at the time, but is going to mean a lot in the end was he did this situation where he had a board hooked up to a positive line, then he had the negative lead, and it was contacting a metal sink that went to ground. And when he pulsed the damn thing on and off, the board would go up and down, right?
Mm-hmm.
How significant is that in the end? Because at the end of the day, that's exactly the effect you need. You just need it sustained. That's it. But it's only doing, in his case, it was only doing it for that instant because then, you know, the circuits would be, you know, it's connected because it wasn't configured properly to sustain it. But it did. That's the thing. Sometimes you just got to get to see what it takes to do it, and then be like, okay, now how do I sustain this? Well, that's where the field geometries come in. You know, you got to do it with the ground. The ground is the problem. You don't, you know, when it's running there, and you have a circuit that's running the ground, it's never going to close the system. You need to be able to close all the loops. You know, and that's sort of what it comes down to, I think.
Hmm.
Who do we have
Bernie,
loaded in here? Bernie?
I think Bernie's trying to come in, and it's taking him a while to get in.
Man, that Canadian internet. It's like,
Last time he ended my show, man, on Monday.
yeah, somebody
He
got
hit the wrong
treadmill.
button. It's
Oh.
all good. Bernie, you there?
I think it's Sasquatch.
Sasquatch.
Yeah.
Hey, there he is.
Yeah,
Morning.
Bernie. What's going on, my friend? It appears that he's suffering winter.
Yeah. Oh my god, that's funny.
Bro be chain smoking.
He says, "Old man Bill's built my dragster." Nice. I doubt that's ever true, but that's funny. Oh man. Oh. Well, I don't know what Bertie was gonna say. Hopefully, he'll be down soon by the time we get this thing back together.
Can you hear me?
Yes, we could sort of hear you. It's like you're calling from the space station, but yeah.
Hey. Okay,
Nanu.
how about now? Can you hear me better now?
Yes, sir.
There we go. Hello, good to see you, gentlemen.
What's going on,
Figured
buddy?
I would pop in and say hi, and I'm just headed to a recording studio of my friends called Frequency, and it's an old winery. Well, it's a new winery, but they bought the property not to use it as a winery, but the winery was using acoustic sound as a process in the wine making, and the equipment's left over there. So I'm going to talk to them to hopefully be able to use their equipment to, in the future, hopefully demonstrate some sonoluminescence experiments.
Oh, very cool.
Dude, that's
You
really
know who
cool.
else does that, man? Blacken. You know, Metallica has their own bourbon that they make. And the way that they do it is they make it and also allow it to age while playing the same soundtrack to the same barrel over and over and over and over again. And if you look up your particular bottle, it will actually tell you the specific songs that were played during its
That's cool.
life to hit your door. And I'll tell you what, it's very good bourbon. Like for what it's worth, like it's for the price, it's not bad.
That's cool. I did not know that.
Yeah, man.
So hopefully able to do some sonoluminescence, but we didn't get the track done with my other buddy in time. So maybe it's just going to have to wait till next week or I guess 2 weeks. I'm leaving Kelowna finally on Monday, and then hopefully finally flying to California next weekend. So yeah, it probably will have to wait till it'll happen at Nathan's, which is even better because then we could do sonoluminescence there.
Nice.
Very cool. So when's that looking like? When's that happening?
Well, I'm in the process of finalizing details, so I don't know the exact specifics yet, but I should by Tuesday.
Very cool. Well, you'll have company for Christmas. Looks like, Nathan.
Right?
Right on.
Maybe. We will see. But I was listening, and great discussion today, and love you guys, and we'll probably see you on League of Extraordinary Adventures if you're doing that. And I look forward to calling out the James hoax, and maybe if you can, Nathan, ask Traveling Fools if I can join, because I would love to be a part of that, because that Uranus probe of dark holes, well, we've been calling that since day one, and it's good that it's finally being exposed for the scam that it is.
Yeah, bro. He totally chowed us. You know, he gave us one of those. You know,
Right?
he gave us a chow.
And it's like how that guy got so many views is just, it's ridiculous. And he started out like his first interview on Traveling Fools, and well, we kind of roasted him there, and then people got mad, and it's like, well, it was a scam. What do you expect? But yeah, it is what it is.
And then right after that, we everyone was scared to like have to like step on people's like stories that they were telling, and then we get that joke hole that we start like involuntarily laughing about it. It's like that's the worst thing. It's like,
Right? It's like, oh, the guy's getting views. How dare you accuse him of being a fraud?
Oh. Yeah. What's up,
Because he's a
Lulu?
fraud, and that's why he's getting views. Because anything real gets censored and suppressed. But yeah, that's my 2 cents. Love Love y'all.
Well, I don't know how much of this episode you caught, but you know, I definitely highly recommend you going back on this one, watching it in its
I
entirety.
will.
I think you're gonna have a lot to you know,
No, you
say.
guys were dropping some serious knowledge bombs, and I missed about half of it because we're on the road. But yeah, I will rewatch this because
Yeah, no,
y'all.
this is one for you, brother, because a lot
I
of it
know.
came into
That's
the
why I came in
breakdown.
there at the beginning and had to stream it to one of my channels because I was like, this right here, this ties into what I'm doing to
Yeah, it's
Max.
ripping it apart and keeping it separate. And sometimes you can put it back together, you know. Yeah,
Right?
sometimes-
And that is where we're gonna get some undeniable breakthroughs, and it's gonna be interesting and fun. But until then, see you guys later tonight, hopefully.
Right
Check it
on,
out.
man. Catch
Hey,
you then, man. Safe travels.
real quick, Bernie, before you go, we're actually writing the physics behind it. So all the equations are being written with it. So
Amazing.
they should be out in probably 2-3 weeks. We're looking
So
because we got to do a
Nobel
few more
Prize in
tests.
Science,
Nobody's going to steal it.
undeniable.
Undeniable. I'm going to put it out with everything, with the proper test with it. Okay, I've been working behind the scenes to get this done, and it's all going to be free. We're just going to put it out, publish it, make sure nobody can steal it, and try to put it on their thing as a patent, and we're good to go. We've already written the equations once. We're going back over them again. We're making sure everything matches exactly how we describe it, and it adds things to voltage systems that people that simply didn't understand before, and now they're going to understand how they're in there. So it's going to change. So we're going to have one on the low voltage, the high voltage, and we're going to go around to the plasma physics, and then we're going to be explaining the whole field and the theory behind it. And I haven't worked on the propulsion part of it yet. That's going to be the second part, but we'll have that out there. So if we nail the Graviflyer, and I say if, we'll have a full equation out there that they cannot deny and cannot take away.
And nonetheless, no matter what, when the everything is released and the paper drops, the footage that you're going to see that accompanies it, and I'm talking to everybody here, you know, the footage that's going to accompany this is going to,
Right? Well,
you
it's
know,
that you're going
yeah,
to be both
I'm less of words.
experimentally demonstrating it and giving the math, like the physics behind it. So it's like, yeah, a little hard when the math adds up to, and you have the experimental demonstrations to deny it. And
Oh
I
yeah, no,
look
let me
forward
tell
to
you,
it.
the evidence is not only there, but it's like I said, it's next level. It's impressive, and it's, you know, we're all here for it. That's the thing, you know, right? We're all here for it. So very, very cool.
That's just taking a while. Sometimes you just got to make sure you do the little things to make it right.
Yeah,
That's
unfortunately,
real
this is one of those.
science.
Sorry, I was just saying. Unfortunately, this is one of those situations where, like, you know, your progress in terms of you know, making things usable and doing the experiments and showing it, it shares its time with having to prove the shit to people that wouldn't otherwise believe, and that kind of sucks. You know what I mean? Because like at the end of the day, if you didn't have to prove it to anybody, if you could just focus on doing and be taken seriously, you'd have a lot more time to do it. But instead, what ends up happening is you have to spend all
Or
this time
also
to
get funding
convince
for it,
people.
right? It's like
Yeah,
we're funding everything ourselves. That also takes more time, but it's going to be undeniable progress, and then the steps afterwards should be a lot easier.
right on.
Yeah. Well, I'm gonna
All
have
right,
it done
much love, my
without.
friends, and talk to you.
Right on, brother.
See you tonight.
I think one of the good things is we're doing it without the funding. And I'll just say it this way: I don't owe any of this to a funding source. You know what I mean? They don't get to take it. They don't get to change it. They don't get to do anything to it, man. They get to accept it. That's what they get to do.
Well, thank
Man,
you, Dennis,
Darren.
for funding this.
Yeah. We're gonna send Darren a plaque, man.
That's it.
Him and Ulysses been taking care of me. Thank you, Darren, very much for that, brother. Yeah, there's my funding source right there. You guys, man. You guys take care of me. Right on. Darren's got a bunch of Tesla coils that I built, and then he got a printer and printed out some of the plastics himself, man. They're pretty bitching, man. I'll tell you that right now. The stuff he's doing is awesome.
Definitely. Yeah, isn't it? It is nice being, mastered by no one, right? Like that's sort of the deal. You if you do it all yourself, it's your baby.
Yeah.
Yeah.
Well, Joe, you'll be proud. We wrote it in physics terms, not in Nathan's unrecognizable terms to physics. We did it in proper physics terms.
Well, it has to be. You got to convince people. That's what it comes down to. Making analogies to garden hoses doesn't work with these people, unfortunately.
I had to read space time probably a lot and write things whatever, we'll just say it that way. Some things I may not completely agree with, but for the sake of everything, I wrote them. So, because I guess they know something I don't at this point, but I doubt that. So,
Yeah, I'm not so certain. But you know what? Like I keep on saying, we're all here for it. Everybody that's here right now is playing some kind of role. You've
yeah.
said something that sparked that conversation at one time, or you gave your support just to show up and keep all of us going and motivated toward it and focused on the goal. And like it's important to recognize everybody at play. It's a much bigger cumulative effort than anybody might realize or think, but at the end of the day, man, Sean, he's got it going on with all this stuff, and you've got it going on with everything you're doing, and it's awesome to see, and hopefully in the near future too, probably right at the right time, because timing is always key. When everything kind of comes into fruition, I'll also be in the position to start meddling around with some stuff too, and then we can all do it,
Yeah, you're in there with us, man, no matter what. So,
Oh yeah.
I want to give a shout out to Robert Lightspeed out there, man. He's doing a tremendous job on a lot of this stuff. So hats off to him, man. And he came on and did an interview with me a few weeks ago, and he'll be on again talking about this stuff. So
Yeah,
dude,
no, that guy's cool, man. He had a really good take on it, and look at how it all ties in. And I've been saying that since the moment I saw what he had to say. It's like this is, he took everything we were saying and turned it into the man. So
oh yeah, I should bring him on next time, Joe, when you're on, so we can all three talk. I think that'd be pretty bitching.
yeah, definitely, yeah. If you're around on Fridays, man, see you then.
Right on, guys. I just want to thank everybody in the chat, man. You guys have been awesome tonight. Appreciate you guys all sticking with me on this, especially those out there who have been with the Graviflyer project from the beginning, man. And then now getting to the point where it's actually getting to tremendous progress, and we had to take some breaks to learn some more things and to understand the engineering behind it a little better. So I just want to say thank you for everybody sticking in there with me. And then also want to thank Darren, man. You hooked us up, brother. Every time, man. I really do appreciate that. So, with that said, Joe, you got anything?
Nope. Oh wait. Yes. Happy Thanksgiving.
Oh, well, happy Thanksgiving, everybody. That's right. It comes on before we're here next Friday, right?
That seems to be how that goes. Yep. So we'll see you on Black Friday, and peace and love.
Right on, guys. Thank you very much.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.